So hello and welcome friends to our channel Intro Mech, where we discuss about basic mechanical engineering concepts and many other things which are related to the automation industry. So guys, we have started our new series regarding to the special mechanical devices, and in our earlier session we have started looking into the automatic tightening systems, and Nutrunner is one of the most widely used system for that. So today we will see what is exactly the Nutrunner system and how we can use it for the different systems. So without wasting time, let's get started. So how to select the Nutrunner system? That is the important thing. So these are the different parameters like tightening torque, location, size, variety of bolts, cycle time, type of machine. So first and the most important thing is the tightening torque. And where you will get this tightening torque? The customer drawing. So from the customer drawing, it will be mentioned like which type of bolt is there and how much tightening torque it will require. Sometimes they will provide the range, so that is how we should look for the tightening torque, or we can always ask the customer like how much torque is required for the tightening of this bolt, like how much allowable torque is there. Then second come part is the location of the bolt. So this factor is very important, as the location. Now you can see these bolts are on this space. Some bolts can be at a critical space. So mm, according to that, we need to select the mouthpiece, the head of the nut runner, whether it should be a straight or at angle. Then the size of the bolt, definitely from that this torque will vary, and from that the series will vary. Then the variety of bolts, whether we are tightening only one size of bolt, the different sizes of bolts, whether it is a bolt, whether it is a screw, whether it is a nut. So those things will matter. And then comes the cycle time. So this cycle time is very important, whether we are using like a manual system, a semi-automatic system, or a completely automatic system. Then the type of machine. So whether the customer want a manual machine, so it might happen that the customer has a very less budget, or the application also not need a um, semi-automatic or fully automatic system. So depending on these kind of requirements, we need to select the Nutrunner system. So let's consider uh, one machine. So this is kind of manual tightening machine. Here you can see the requirements. The design a machine for tightening bolts. The bolts will be pre-inserted into the part. So the bolts which we are required to tighten will be pre-inserted into the part. The tightening should be done manually. The nutrunner can be attached to an overhang spring balancer or torque reaction arm, or can be loaded in a parking space near machine. So these are kind of inputs we have. So with this we can have this different arrangement. Here you can see this is the nut runner, which is like operator is manually using this. Here also operator is manually using this. Here you can see it is attached to the overhang system, where what which is also called as a torque reaction arm. Now here you can see this torque reaction arm arrangement. Now what is the torque reaction arm? So whenever you will be tightening this bolt, it will be having a reaction, it will be having a torque reaction. And as you are manually holding this system, after some time it will be a fatigue to the operator. And that's how, in order to take that reaction, we have the torque reaction arm. Here you can see the spring balancer is there, to which this system is there. And also this system offers a good positioning of the nut runner. We can easily move these handles, so that is also one advantage of the torque reaction arm. So now this is how we want to design the system. So let's see how our system can be. Now this is one kind of a desorter handheld tool, the torque reaction free tool, high flexibility, tack time, airless system, low maintenance cost. So Desauto is one of the manufacturer of different types of nut runners. So here we can see the operator has taken it from the parking, and now it is manually just uh, pressing the knob, and the bolts which are pre-installed into the system, uh, right, the bolts you can see are pre-installed into the system. We are just tightening or losing the bolts. We are not having any kind of automation over here, right? And we are getting the output, the torque we can read, like whether it is according to the requirement or not. So these kind of feedbacks we can get, and these kind of neutrons can be having different, it can be electric, it can be, here you can see now it is connected to the electric technology, which is also very easy to use, right? And then this kind of arrangement we can have. So this is kind of a brief explanation about what is a manual system and what kind of nut runner we can look for. Then comes the semi-automatic machine. Now here you can see what are the requirements. Design a machine for tightening bolts. Now the bolts will be pre-inserted into the machine. Now the tightening should be done automatically, and two bolts should be tightened simultaneously. Now this is something which is required into the system. So let's see how our system can be. So here now you can see there are two nut runners into the system which are tightening and losing the bolts. The part is getting fit to the system, and then we have a z-axis. The nut runners are coming, and they are kind of uh, uh, now in the next, see, they are tightening, and after tightening you can see the marking system is there. So this is kind of a automated system. We need to mount our nutters on some Z drive, some access should be there, some automation should be there, but still the bolts are pre-inserted. So that is why it is semi-automatic. The bolts are pre-installed into the system. We are just tightening the system, but our nut runner is mounted on the drive, and according to that we need to select the nut runner also. So this is the semi-automatic tightening machine, we can say. So this is the Desorter company which we were talking about, and it manufactures different kind of tools. So here again we are not promoting any manufacturer, but we are taking it as an example. We can go through its catalog and check out what are the parameters. So we can check the parameters which we discussed earlier, whether they are into the catalog or not. So here we can see the different models and different series. This is our assembly tool selection guide. So we can see n number of different tools available, like battery stand alone, tools are there. So these will be having different toolings, like the end mouthpiece, it can be at 90-degree, it can be straight. So depending on the application we need to check it, we need to select the mouthpiece. This is called as a mouthpiece. Then we have industrial smart hub, electrical DC tools and nut runners, then different specific tools. So we can go through this catalog. I will drop. Then the pneumatic fastening tools, as I was discussing, so we can have the pneumatically operated nutters also. I will drop the link of this PDF into the comment section. Then we have some customized solutions also, right? Then this is kind of different systems and series. So let's check it out, some of the things. Now this is the here we can see the parts. So see, this is like high accuracy clutch is there, brushless motor is there for tightening. Then uh, this is the mouthpiece. Then we have the trigger, the batteries are there, and the feedback system. So here we can see the different models and what it is offering. So according to that we can select, right, and here the main part is there. So we can see which type of tool is there, and angle head, which angle head is available, the torques. Here you can see up to which torque they're offering. Now in this catalog you can see this is range is given zero point 0.4 to 60 Newton meter, and the RPM. So the RPM is depend. So RPM is required, that will decide your cycle time also, how fast you are inserting the bolt, right? So here we can see some models and the part numbers, the torque range, which that is why we require to know how much torque we want. Then the rotational speed, that will dependent on your cycle time, right? And then the output drive, now that is nothing but dependent on your size of the bolt, and here comes the size thing, right? So that is how we need to see whether it is female, male, hex, what type of bolt is that, whether it is socket head, whether it is hex head, what is the size of that bolt, whether it is 1/4, 1/8. So according to that we need to select the mouthpiece also. For some of the nut runners the mouthpiece is replaceable, we can attach and detach. For some nut runners it cannot be detached, so depending on that we need to select. Now this is kind of some other series also. So we can see the different parts over here. So this is torque transducer, accuracy, long spiral cut, bevel gear. So as it is transferring the motion to 90 degrees, it will be having the bevel gear arrangement over here. You can see it is 90-degree angle mouthpiece, right? So it will be transferring the motion over there at 90 degrees. Then we can read the key points: high technology, quality control, right? So this is kind of another series again, and you can see again the torques, the speed, the weight, and this is the next series, which is angle head. With angle head, this is the angle head, and we have A, B, C different series over here. We can see the dimensions. So these dimensions are also important because we need to assemble, we need to attach, we need to insert it into our machine. So we need to check the dimensions also, whether it will get inserted or not. So we need to check the dimensions of the Nutrunner also, and the square drive. So it will show which kind of drive it has at the end, and what is the size. You can see 1/4, 1/4, 3/8. So that will be also there. We need to check it according to our requirement. So different sizes are there. Then the torques are given, speeds, the dimensions and the size will vary. Quick change, some tools will offer the quick change mouthpieces as I was discussing. So here in this series we can see the, so now this is a different series. So let's check it out. So output drive, so output returning type, here you can see the quick change chuck. So what does it mean? That you can change the chuck, and you can insert the different drive head also. So that is what you can check. So this is all about what are the different parameters we need to consider while selecting the nut, how we can mount, or how we can select the neutrons depending upon the type of the machine also, whether it is a manual, semi-automatic. So this is it for our today's session. In our next session we will see uh, how to select the Nutrunner for the fully automatic system. So if you have any doubts, please do write into the comment section. We can discuss over there. Until then, keep intro making. Thank you for your patient listening. Thank you.